and it could take a while for us to go up to that last mile. We have a very good panel, quite an interesting topic: accelerating technology adoption, comma, innovation, comma, I'm a lawyer, and investment. So when I think about Africa, I heard so many times, this is really the place to go. It's happening, it's coming, it's there. Well, it's not yet there, then they said. I think this is changing, actually. And it's changing when you go to Africa. Someone said this morning, you see cell phones everywhere, massively used everywhere. What's also quite recent, with the new energy technologies, you see renewable technology, decentralized, very local, everywhere also. And what's attractive and interesting, you start seeing the combination of the two, cell phones and power. Not only to power the cell phones, but also using power and cell phones to reach internet and to increase and accelerate the development of rural areas in Africa. So technology is really becoming the game changer here. And as you know, I'm the CEO and chairman of Friends of the Supergrid. It will not be only lines, it will also be decentralized grids. But I will start my panel with, and some of the speakers have slides today, with a short presentation that Ahmed will give you about the real and only supergrid in the world. I'm chairman of Friends of the Supergrid, but as I said, we are lawyers and we sell wind in some extent. Renewables. But Ahmed, he isn't the real guy, the real thing. He has a supergrid, and it's the only one in the world. One special feature of this supergrid is that it's going through 6 different countries and owned by 6 countries. Ahmed, I will let you continue the presentation, but if you want, I can do it also.
Thank you, Pierre. I think you know all about it, so it will not be anything new for you. So good morning, ladies and gentlemen, and I'd like to share with you some of the development that we had in the GCC. For those of you who were here yesterday, sorry, there will be some repeated things. So I thought I'd talk through a presentation, a short one. It's only 72 slides. So I'm just kidding, it's only 50. The GCC Interconnection Authority, it was an idea to connect the 6 GCC countries for a long time, since the 80s. And finally, in 1999, the 6 countries of the Gulf, not the Gulf of Mexico, the Arabian Gulf, of course, they came together and they said, well, to do that, we need to create an entity that will take care of this interconnection. So in 2001, the GCC Interconnection was established as a joint shared company by the 6 countries. So we are run as a company. We have a board from the 6 member states. Now we are running into our 10th operation year. We started operation in 2009. And during this time, we had rendered support to all the member states in terms of emergency support during emergencies. We had more than 1,600 incidents where we managed to give this kind of support, and we avoided load shedding and blackouts. In the early 2000s, the GCC countries have witnessed several blackouts, but since the start of the operation, we managed to avoid that, although we had some major incidents in the member states. Moreover, I think we have annual savings for the member states which exceed $400 million, basically because of savings in investments in generation capacity and sharing of reserves. And this is our headquarters, which is in Dammam, Saudi Arabia. You see it symbolizes 6 countries. It's like 6 cubic shapes connected together, symbolizing the unity of the 6 countries. So our grid is actually a unique structure. It's a regional backbone structure, unlike the neighbor-to-neighbor configuration for interconnections. It spans more than 1,000 kilometers from Kuwait in the north to Oman in the south. Electrically, it is an N-1 configuration giving a maximum of 1,200 megawatts. So the maximum capacity actually is more than 2,000 megawatts. The volume of power exchange over the past years shows more dependency on the utilization of the grid. So you can see how it's growing over the year. But these are just unscheduled exchanges based on emergency support and balancing. However, the significant part is where trading has started to evolve now. For the last 2 years, 2016, 2017, we have seen some significant level of trading happening between the member states. And we are hoping this will be coming more because basically we see major potential benefits from the economic power trading, which would be more than $2 billion per annum over the 25 years. And also there's a reduction of 9 million cubic tons per annum of CO2 emissions. And these are significant benefits that we are targeting to achieve. And we want to achieve that through the development of the market. Now, our mission, as we define it, is interconnecting our world. We've managed in the first phase of our existence to establish the GCC interconnection. Now, the two things that we are focusing on is, number one, creating the GCC power market. And this is a process that we're in the middle of. And also connecting beyond the GCC region by expanding the grid beyond the GCC. For our GCC market setup, we will continue to be the transmission system operator of the GCC interconnection, providing a balancing market. However, we're looking to create the GCC power exchange, which will start with the day-ahead market and then intraday market and forward market. So this is part of what we are trying to develop. When it comes to going beyond the GCC, we're looking to external expansion into different regions. As you know, the GCC is right in the middle between Africa, Asia, and Europe. And we think by expanding the network towards these continents, there will be significant complementarities between the GCC system and other regions, including Africa, which I will come to now, that will really produce lots of benefits for for both sides. So this is partly what we are looking at the high level. And now, going from the current grid, this is our current grid, basically extending from Kuwait to UAE and Oman. And these are part of the paths that we are looking at. Going north towards Iraq, towards Jordan, Syria, and also, if this clicker works, going to Egypt as a pathway to Europe also, and to the east going to India and Pakistan, and going to Africa also through Yemen and Oman. We're also looking to connect joint large power plants, grid scale renewables in terms of wind power and solar all over the grid, which will increase the economic viability of this grid. On the bigger picture, we're looking to have regional and intercontinent interconnections with the Arab world and the other regions around us, which would be looking like this. Let's talk about Africa. Africa is a promising region for renewable energy. This information is from the IRENA report. There's huge hydro potential. There's huge wind potential. There's huge solar potential. I think all of you know it. So I think it's worth it really to put plans to exploit it. We took this information from the Eastern Africa Power Pool Master Plan, and it shows that in the current situation there are a population of more than 500 million with an access rate of 60%, which varies between 5% and 100%. Power consumption of more than 200 terawatt hours per year, which 75% is in Egypt, where most of the, I think it's the biggest in Africa. But to look into the master plan that, about the large generation investment that are foreseen, there are lots of these under construction. And also there is a need for transmission investment to make sure that these can be connected. Now, the takeaways of this is two things. First of all, the GCC interconnection as a backbone can be an option for an African supergrid development. Now, I don't mean to have a backbone all over Africa, but there are some clusters that might that might utilize this kind of model, especially when you have large-scale transmission of power, especially if you have, for instance, large hydropower, like what you have in the East Africa, and you want to export it to other countries. So that would bring, the viability of this kind of model. So I would encourage, maybe studying this kind of models for as part of your network. And also the potential complementarities of energy mix between the GCC and the African system. Of course, in the GCC, we run currently on fossil fuels. We will be very much interested to import hydropower from Africa. I think this will be a much needed power for our network, which is growing actually in a very high rate, also 6 to 8% per annum. And also exporting the abundant renewable energies to the GCC and neighboring countries can bring significant source of income to Africa. Thank you for listening.
Thank you, Ahmed. Our next speaker, Doug, you're with the NRL, Renewable Energy Laboratory. The stupid lawyer I am, Lawrence. When he was a kid, he was always afraid to go to the laboratory because that was synonym of torture room. I guess physics, biology, and these things, strange numbers. Tell us about what's happening there in terms of renewable energy and innovation and technology. And you have a couple of slides too.
I do, thank you. Yeah, thank you, Lawrence, for the invitation, and Pierre for the introduction. Yeah, so I grew up on the other side of the equation, writing a first paper on solar energy in high school, thinking about the physics and how much light comes to the Earth. And it's kept me on that track for a long period of time, a PhD in actually physics and chemistry. But today, let me talk about the Power Partnership. So this is probably new to most of you, so let me set the basis for it. The 21st Century Power Partnership is an initiative, as Lawrence mentioned, of the Clean Energy Ministerial. That is a gathering of 23 energy ministers plus the European Union that get together at a leader level once a year, and then they promote and advance year-long or continuous efforts that do technical assistance and sharing of best practices, et cetera. And there are many of these initiatives. There's efforts on energy efficiency, efforts on electric vehicles, et cetera. The Power Partnership was formed about 6 years ago, really thinking comprehensively about power sector reform, about putting in the stable policies and regulatory frameworks that allow to attract investment, that put solid financial viability around both the distribution system models as well as the wholesale models in a very changing and a very evolving world with distributed energy generation, more renewables, more efficiency, and certainly the IT components that we've talked about for the day. And so this is kind of the framework of the Power Partnership. We do that in a comprehensive way of looking across all of those different elements and trying to synthesize those, then working with you all, the regulators, maybe the departments of energy, on what does the policy and regulatory framework need to look like. And coming from a laboratory, we actually bring best practices into that, both a technical best practice, but also a policy and regulatory best practice from scanning across the world. So it's not just NREL that's part of this, it's Lawrence's team and many connections through his network, but also a network of international think tanks and best practices, universities, and others as well. And so the whole idea is to accelerate the learning process, particularly appropriate for some examples in Africa, some examples in Asia, as well as, I think, bringing some practices to the GCC, thinking about the supergrid. And there are a couple pieces I'll pull out, I think, which are already in the pipeline for being able to integrate renewables, as you laid out there. There are a lot of partners already in this system. We are happy to have more partners join it. One does not have to be a member of the clean energy ministerial countries to be part of this network, and we are open to sharing principles and best practices through this, as well as a sister initiative, which is called the Clean Energy Solution Center, which actually has a very cute little tool on it, which is called Ask an Expert. And literally, you have a question, you go forward with it, and we work through our network of experts to help pull some resources in to help answer questions. But let me share just a little bit of what we've done. And here you can see 4 or 5 or 8 of the best practices reports that we've put out over the last 5 or 6 years. These are all available free of charge up on the website. They're supported by multiple different governments and foundations. And we hope that they are resources for you all. And please do tap into them. And they're written in English. There are a couple that have been translated to Chinese. But for the most part, they're in English. And this is everything from thinking about the future to understanding flexibility to distributed generation, regulatory roadmaps, to understanding smart grid roadmaps, and things like that. Most importantly, if I can put up the next piece, what we also do is apply those nerdy best practice tools to helping you all or counterparts like you understand and evaluate the technical feasibility and, frankly, the potential for raising the ambition of meeting clean energy goals. Both energy access goals, even though this is only a wholesale map, we can also do distributed generation. And what you see here, what I want to put this movie up with, and it's not Africa, it's India, because we worked really hard to do this. And this is something that I think is really important to recognize. We worked with the power sectors of India, the utility companies, the system operators, with 15-minute data for the whole year, including the wind and the solar data, the demand data, the generators. And what you're seeing in here is a movie that's running and showing the power generation, so the plot down on the lower right, of meeting load with N-1 contingency and regulatory and regulation reserves, et cetera, in the system. And you're seeing the sun come up, and now you see this big yellow bubble come on. That's the solar energy coming online. And we know where it's located because we can do the economic calculations of where it's located. And if you click through, we also can then explore different scenarios. That was the Indian 2022 national goals. But now we can actually look at transmission flows. And so now we can see where transmission flows in one direction or it reverses direction. And we can see where constraints are in the system. And we can evaluate where, I would call them, transmission corridors are needed in order to basically bring these resources online. And all of this is done within a least cost economic planning framework. So I think I just stop there and give you a vision of how you can apply best practices and tools, terabytes of data sets, and really help inform your own planning and, frankly, your own exploration of what clean energy or what energy futures look like in the future for you all. So welcome questions, and thank you.
Thank you, Doug. You do this in everywhere? Any country?
We can do it in every country depending upon the data. So we have the resource data generally, almost in every country, working with the World Bank, working with our colleagues at USAID and IRENA and elsewhere. It's the demand data and the transmission line, the current transmission line. So getting a good sense of what the current system is, we can then, with fairly good rigor, explore the potential future systems and help advise and provide some insights to where investments might go, how the system would operate, how it might impact the current thermal fleet. So one of the key insights out of the India program was that the thermal generator fleet, which is actually by regulation not allowed to ramp very deeply, 50%, was going to constrain, i.e. cost more, for the whole operation of the system. And so the Indian regulators now working through how do we allow the thermal generators to have more flexibility, and of course how do we remunerate them for that flexibility as well.
And this is funded through an international program?
The India work was funded through the Power Partnership in partnership with USAID and the World Bank. In Mexico, we do the work in partnership with the Department of Energy down there, the regulator, CFE, the system operator, et cetera. That's funded by a foundation. But it's a flexible model in terms of how the technical assistance can be delivered.
Okay, thank you. In legal language, what he just said, it's a flexible model. It means we can negotiate the tariffs. Okay, Justin, you're with the electricity company in Côte d'Ivoire. Thank you for joining us today. So please give us your take about technology adoption, innovation, and investment.
Okay, thank you. First of all, I would like to introduce my company. Compagnie Ivoirienne d'Électricité, CIE, is a private operator in Ivory Coast. We signed in 1990 a contract with the state. In this contract, we have the monopoly on transmission and distribution for the country and import and export. We are also involved in generation since we operate and maintain all the assets of the state, owned by the states, hydro plant, 6 hydro power plant, and thermal plant. In the distribution side, we have we provide service to 1.9 million customers. It is small compared to the population of the country, which is 23 million. So you see that we have a margin. And we are listed on the regional stock exchange of Abidjan. I think that's very singular for a company in Africa. So we have stakeholders in the population. Okay, concerning innovation, I think that's very important for us because our remuneration is a flat remuneration based on the kilowatt hour billed and collected. So we have an incentive to be very efficient. And the way in many countries of Africa is innovation to be more efficient, to reduce operation cost, and to make benefit. The challenge in many Africa countries is that the tariff is controlled by the states. We have a market, the design of a market is a single buyer model, whereas the state is a single buyer and it sets the tariff. And it's difficult to have tariff, cost-reflecting tariffs. So innovation is a way, as Mr. Abel said earlier, to provide more flexibility and to improve the performance. And ICT provide many solutions for us to make some big improvements. I can mention a few examples, if I may. We talk about the revolution in cell phones with mobile money. And by 2012, we experienced a lot of queues in our agency because people wait for the last day to come and pay their bills. It was very difficult. People were standing online on the sun and things like that, or on the rain. and it was not acceptable for the image of the company. So we look at new method of payments, and we saw that mobile money will be a solution. And we introduced that in the company, and by now, almost we reached more than 50% of the transaction for payments of the bill and for other services are made through mobile money. So in 2012, we were planning to build 5 agencies to accommodate the people who come to our cashier to pay their bills. And we save, each agency was something around $1 million US. We saved $5 million not building agencies. So you see that's something important for us. And also another example will be with smart meters. A big challenge, or another big challenge also for utilities in Africa, is electricity fraud or illegal connection on the grid. And that technology provides us more tools, because those smart meters, they have communication. You can install those smart meters in an area, and with a concentrator at the distribution substation, and you make real-time balance to see what comes out and what is consumed by the customer. When you see the ratio going down, you see that there's something wrong in that area. Before, we were sending our team, control team, without any special target. Now we can do it more efficiently, and to bring those teams for controlling the meters where we know that there is a problem. So it saved time, and it saved also money. And we experience also the control of public lighting with those smart meters. You can do remote action with those meters. And so we don't have now to see public lighting during the day, because we can program those meters to cut the power at a certain time. And we don't rely on the former devices we call lumenda in French. I don't know if it's the same in English, where when there is dark, they actually turn on the power. And also, we can control better the consumption, and it's more transparent for the municipality who pays those public lightings, because when they see the light during the day, they say, oh, we didn't ask for lights during the day. We won't pay the bill because it's not relevant to the consumption of the public lighting. There are many examples like that, and we think that it's a way for utilities, African utilities, to improve efficiency, because one of the main, also to add what Mr. Abel said this morning, to attract investment, utilities also have to do the homework to clean the financial, to be more financial credible, and to show transparency, and to know, because all the other segments of the chain of value in electricity depend on the distribution company to do good billing and collection revenue, to be able to pay for transmission and power to the generators.
Thank you, Justin. Is your company also supporting the development of rooftop solar net metering systems?
Actually, my company is involved in operation and maintenance. So for policy, for investments and development of the electric sector is a responsibility of an assets company. Mr. Traoré, the MD, was supposed to be here, but he couldn't make it. So the technology that should be implemented in the country is decided by the minister. And as a private company, we are preparing, as it was mentioned yesterday and in other presentation, we are trying to be ready. So in our training center, we are already working on those issues, and we have solar panels pilots and things like that to be ready when the legislation and the context is okay for that.
Thank you. Ahmed, we saw from your presentation there are plans, projects to link the GCCIA with other geographic areas than just GCC. We saw the links with Ethiopia. How would you qualify, what would be the key challenges to make sure that the expansion of the grid in this region can be done?
Well, there are major challenges. Basically, for us to go this distance, I think there are lots of challenges in terms of going through unstable regions, like what's happening in Yemen. Although we're going for, when it comes to technology, we're going for HVDC technology because of the distance. But I think the main thing is to get the model that will work for these countries, the right model that will work. And I think Africa has a good opportunity here. First of all, starting a little late lets you learn from other systems. Learn from other systems in terms of experience, in terms of what is the right model that will work for you, and not necessarily copy other models. The other thing is that technology, as technology is evolving, you can have the latest technology. And we, in our system, in the GCC, since we just commissioned our grid 10 years ago, we try to employ the latest technology because the technology will be an enabler. Our grid spans over a big geographic area, which will be similar maybe in Africa. So we are utilizing technology to capture all the information, do more remote operations, remote investigation, and remote monitoring, so that we can minimize the requirement to go physically to that. So these are some of the challenges that needs to be looked at when connecting Africa with the GCC.
Thank you. I hear roaring stomachs here. So before I have to let you go, guys, but some questions from the audience. Can I have a mic there? Thank you.
This is John Sager from MCC. I guess one question I have for you is that power theft is a challenge. How are you using innovation to do that? And is the innovation also at a political level in terms of being able to encourage enforcement of basically what is unlawful activities?
Well, actually, it's working. Okay. Before 2014, there were very much difficulty to run before those illegal connection and things like that. But the state provide us legislation to better, I should say, punish those who were doing that. But the technology came as a tool because besides stealing electricity, people are living in urban area, and a lot of them come from the rural area, and there are some communities. They need electricity, and as I mentioned before, people can't afford to pay for the connection. So they have some illegal people who connect and sell them electricity at a higher price, even higher price than the regulatory tariffs. So by doing some operation to disconnect them, we bring prepaid meters and smart meters for them to be able to pay at their own rhythm, if I may say. So it's a complementary, action with a legal aspect and technology. I don't know if I catch up your question clearly, but that's what I can say.
One last question, Abel.
Yes, the question is a little bit sensitive. It's addressed to you, Ahmed, and indirectly to Justin as well. You are serving a big territory, and we all know that there is a political problem between Qatar and the rest of the GCC members. Have you had to stop supplying Qatar with electricity as part of a blockade, or how do you resist that? Same thing will go for Justin, if you've ever had to stop selling electricity to a country because there was a problem with that country. And for you, Doug, the question that arises, you said ask an expert, and you are my expert. People don't talk about power factor when it comes to renewable energies in terms of figuring out how economical they are. So could you just enlighten us a little bit about that issue? Thank you.
Ahmed, before you reply, as a lawyer, I may advise you to require Chatham House and confidentiality.
I think Lamine is trying to cost me my job, I need to have a job when I go back, But frankly, electrons don't understand politics. And what is happening is that our particular model, the way that we were set up as a company, everybody is a shareholder. So we don't get into these kind of political things. So we have continued operation as normal without any kind of interruptions. We have also managed to schedule our board meetings, joint meetings for the joint operating committees, joint planning committees at locations where everybody can attend. So we are weathering out this kind of political situation, and this I think this is part of the strength of this kind of model. Being away from the neighbor to neighbor interconnection, being one neutral entity, I would say, that doesn't get into this kind of political situation. We just worry about operating the grid in the best possible way and delivering the service to all of the shareholders that we have. So luckily, so far we are okay, and hopefully this political situation will go away very soon.
Yes, to follow up to this question, effectively, Côte d'Ivoire has a tie line with Ghana, as Jonathan said, a tie line with Mali and Burkina Faso. And Côte d'Ivoire went through a crisis from 2002 to 2010. And we never, the country was divided in two with rebellion on the north. You see the Thailand with Mali and Burkina is on the north. But the elections continues to flow during that crisis, and nothing, we were not really concerned with political and military concern.
And I'll take the last one, which is how do we deal with essentially the variability of renewables when we think about power system modeling? And so there was actually one slide that I didn't put up, which shows we actually have a tool suite that goes from essentially frequency stability of a device all the way up through a system to the planning tools that span into decades. Each of those tools is expressly enhanced by the knowledge that renewables are site-specific, typically. I'll just say wind and solar are site-specific, not renewables overall, and variable. And so, for example, that map was created with 15-minute data and has to achieve reliability factors every 15 minutes at that level. So we can also go to 5-minute data, or we can go to real time, et cetera. So that power quality, the power factors, are built into all of the modeling, and they're tested. They're there to be pushed on and to provide essentially confidence to you all as the utility companies that the system can operate reliably when you integrate that many amounts of renewables, either at the distribution edge or in the wholesale side. So there are a couple other pieces I forgot to mention, which is we actually have done this work in South Africa as well. I don't have a map for that. I think that that's important. That was working with the utility and the other stakeholders down there. Very important for their medium-term resource plan. And then it's also very scalable. So I showed you actually the whole country of India. That's actually a relatively large system. You can go down in scale to look at a community or a distribution network, and that's a different level. Or you can actually look at regional grid integration at relatively significant detail. And so it's a toolkit that's there for leapfrogging. And we hope that you'll all embrace that, and we're happy to help with Lawrence and others to really bring that capability forward.
Thank you, Doug. As concluding remarks, I would like you to keep the words of Justin and Ahmed, and those of Doug also, of course, but Justin and Ahmed, you refer to electrons as being neutral, and in these neutral politically, in these shaky times, sometimes troubled times, I remember when I was younger, we had ping-pong diplomacy. Maybe it would be an idea to use electron diplomacy to make sure that we have peace in our world. Thank you. Please join me in thanking this panel. You have to remain seated, if I understood Lauren's word. I don't know why, but thanks again. Thank you.
All right. Thank you. I asked them to remain seated because I know what